Hello everyone, welcome to Data Advocate channel. This is the first session of dimensional modeling where we will understand what is dimensional modeling. We will understand what is the star schema, what are the different processes involved in the dimensional modeling, and how we can design the star schema. So let's start. Let's take on a real-time scenario where a retail grocery store has multiple outlets in a city. Now, the CEO of a company wants insight on the data that how is the store is performing. So now a single retail grocery store will generate millions of raw data, and if anyone want to build the report or graphs on that raw data will be very tough. So how to resolve this? So this can be resolved by building the BI system where these raw data will be stored, filtered and transformed in a data warehouse, and the data warehouse can be used for further reporting process. So this data warehouse will be designed by using the data dimension modeling, and data warehouse will be not be similar to how data is stored in the transactional system, where taking the transaction is important concept, but data warehouse is more focused on the performance because you have to store the historical data as well. So the important concept here is you have to use the dimensional modeling, or that dimensional modeling will help you to achieve the star schema. So dimensional modeling can be used to design the star schema, as well as if you're working for the semantic layer where you create the cubes, right? So to design the cubes as well, you can use the dimensional modeling. So while designing the dimensional modeling, two important concept is it should be understandable to the business, because the reports will be built for the business, and business should be able to understand how dimensional modeling or how your data warehouse or OLAP cube is designed. Another important point which should be taken care of is the fast query performance, because you are going to store millions of records for historical analysis as well, and any reports who is using this data should be efficient enough. So now dimensional modelings implement the relational database as a star schema, where you have the fact at the center and dimensions at the which will surround your fact table and which will look like a star schema. So we will understand in our next few slides what is the facts and what is dimensions, but here you can consider this as when you design the use the dimensional model, you design the star schema. And why star schema? Because star schema is a denormalized form, so you have number of tables is very less if you compare with your OLTP system or transaction system. So it's easy to write query, you don't have multiple tables to join. You know the join conditions very well because your fact table will have the foreign key which will help you to join with the dimension tables. It will be very good in the performance because of the denormalized structure, and it's also good because it will be used for the reporting purpose. Aggregations is very easy here because you have the separate dimensions and you can easily do the group by based on the different dimensions. So what are the important steps for dimension modeling? The very first important step is business process. You have to select the business process. We will discuss this, like what is the business process, and then we have to declare the grains or labels. Then we have to identify the dimensions, and then you have to identify the facts. So let's take a real-time scenario where there is a retail store and the daily transaction is processed through the purchase of items, which can be considered as a business event. So here you identified the business process, which is the daily purchase of items. Now this daily purchase of item will generate the raw data in the form of transaction date, order, customer ID, sales amount, product name, sales quantity, right? So now the scenario here is you have the raw data. How you are going to design your data warehouse which will be used for the reporting purpose, because your business user might want to see the sales performance of last 4 years or 5 years based on location of the store, based on the product category, right? So how you can build the star schema and which can be used for your collab cubes or reports. So now here we identify the business process. Now the next step is you have to identify the grain. So grain you can consider as a level. So suppose in a retail transaction system, which we just see here, the order labels is the level. Or you might have the scenario where one order has multiple items, right? So you can even consider the item level. So it depends on the business requirement, like how low you can go to select your levels. But the most important thing here is the focus should be on the atomic grain. That should be consistent across all dimensions and facts. So in a star schema, all your facts and dimensions should have the same level of grains. So what I mean is, if you have selected the grain as monthly level, where you are calculating the sales amount at month level, so your whole fact and dimensions should be at month level only. So these are the few examples of the grains in the real-time scenario. One we already discussed. Another is the ticket level data in a train reservation system. So in a train reservation system, business process is the booking of tickets. Now the levels is ticket. So when the process happens, ticket ID is generated. So now you can consider the very low grain at the ticket level, but you can also consider maybe location wise, or maybe the monthly tickets. Another example is monthly snapshot of total number of customer subscription on OTT platform. So it can be monthly or it can be weekly as well. So now you have to identify the dimensions. So dimensions, what are dimensions? So dimensions are the descriptive field which identify about the process. Like in sales process, product is dimension which answers what is sold. Okay. Now, so where this transaction happen, store location. So store is a dimension. Who did the transaction? Customer. So customer is a dimension. What is bought? Product. So product is a dimension. So this is the way where you can identify the dimensions in your business process when you are going to start your dimension modeling. Now same raw data which you translated into the dimensions, you have to also build your fact table. So fact table are the tables which contains the foreign key of dimensions. Like here the customer is your dimension, so your fact will have the customer ID as a foreign key, and numerical values which will be used to create the KPI or measures that will identify how your business is doing. So suppose sales amount. So sales amount will go into the fact sales because it's a measure. Product count, how many products were sold for that particular store location. So this is a measure, right? So how many product stored at what location, sold at what location, right? In what month, right? So these answers, so your model should be able to answer these questions. Now, so we must understood that why we use fact table, why we use dimension tables. Now, so this is the raw data. How you are going to convert this into the star schema? So you know the dimensions, right? Date is a dimensions, customer is a dimension, store is a dimensions, product is a dimensions, and all these dimensions with their primary key will be joined with the fact table. Fact table will have the foreign key for all these dimensions, which can help you to join, right? So now this star schema will be able to answer your questions. Let's take an example. How to find the sales amount bought by one particular customer from last 5 months, right? So you can join the tables, and you can do the aggregations based on the year and based on the customer name, and can find the sales amount, right? Okay, so this is your star schema. Now this is your report. So you want sales amount by city, by brand name, right? So store city you have to group by store city, right? You have to do the aggregations based on the group by. You have to do the sum of the fact sales amount from the fact sales, and then you have to group by the brand name. So this is how you will achieve the report. So what I mean here is, starting from your raw data, how you break your raw data into the facts and dimensions, or use identifying your business event, identify your labels, and then how you answers your business query. So this is the main purpose of dimension modeling, where you can answer the business questions from the business event. Business event can be from the different scenario. What I took is just one simple scenario from the retail sales example, but it can be from banking transactions, it can be from ticketing systems, right? So hope you have understood what is the dimensional modeling, what is the star schema, and how this star schema help you to achieve the or answer the business query. In the next video I will try to explain more on the different type of fact tables, different type of dimension tables, and we'll try to understand more by designing the dimensional modeling or star schema.